In this video, we're going to continue the 1.3a notes page, and we're going to multiply polynomial expressions, okay? In example C here, we've got a binomial times a binomial. They both have two terms, so we refer to those as binomials. In example D, we've got a binomial times a trinomial, okay? Now, back in the day, we used this memory tool called the FOIL method, and we're trying to get away from that. So we're going to talk about this. I'll use the FOIL method in talking about this here, but we're going to talk about it in terms of the distributive property, okay? So what we want to do is we want to distribute each term of this binomial to each term of this binomial, okay? And in D, we're going to distribute both of these terms through every term in the trinomial, okay? So FOIL method only works for a bi times a bi, okay? So first things first, I want to multiply each term in this binomial times each term in this binomial. So I'm going to start with multiplying the first term of each binomial. So 2x times 3x, okay? Then, again, if you want to think about FOIL, it'd be the outside term. So I want to multiply the outer term here, 2x, times the outer term here, negative 5, okay? So 2x times negative 5, okay? Using the FOIL method or distributive property, whatever you want to call it, I'm going to multiply the inner terms, okay? So the two inside terms, I want to make sure those are multiplied together. So it's going to be positive 1 or plus 1 times 3x. And then I want to do the last terms here, 1 times negative 5. Okay, so plus 1 times negative 5. Okay, so think about it as the FOIL method. Think about it as using the distributive property a couple times. It's really up to you. Okay, so now I want to multiply all these terms. Generally, we might have common terms in here or like terms in here that we need to combine later on, but we'll play that by ear. Okay, whenever we see it, we'll deal with it. Okay, so 2x times 3x is 6x squared. 2x times negative 5 is negative 10x. 1 times 3x is 3x, and 1 times negative 5 is negative 5. Now, like I said, in the middle there, you've got some like terms we need to combine. Okay, so once I combine those, my answer will be 6x squared minus 7x minus 5. Okay, so that's how you do a binomial times a binomial. All right, now let's do a bi times a tri. All right, so again, we're going to think about this as a distributive property. FOIL method doesn't work here because I have a trinomial here. So let's distribute the x squared times each of these terms in this trinomial. So x squared times x cubed, okay? Then I'm going to do x squared times 2x, okay? Then I'm going to do x squared times 1, all right? Now we're going to distribute the negative 3 times each of the terms here in this trinomial. So negative 3 times x cubed, and I've got a negative 3 times 2x, and then I've got a negative 3 times 1, okay? Notice I've separated all those by a plus sign, okay? Because I don't want sign to be an issue here. It's really up to you how you deal with that. You can think of it as a negative 3 times a 2x here, which would be negative 6x, okay? It's, how you want to think of signs is up to you. I just always separate these by a plus sign and then deal with the signs later on, okay? So now we want to multiply all these together, you know, so we've got x squared times x cubed, which is x to the 6th. X squared times 2x is 2x squared. X squared times 1 is positive x squared. Negative 3 times x cubed is negative 3x cubed. Negative 3 times 2x is negative 6x. And negative 3 times 1 is negative 3. Okay. A couple things here. We want to look for like terms. And I've got a couple like terms here. So I want to combine those. And then, like we talked about in the previous video, and like the answer here, we want to make sure our answer, our product, is in standard form, okay? So x to the 6th is the largest exponent, so it'll come first, but then x cubed should come next. So I'm going to move this up a little bit. So negative 3x cubed would be next. 3x squared, when I combine 2x squared and 1x squared, I get 3x squared, and then the negative 6 and the negative 3 follow. So notice the exponents go in descending order all the way down to the constant, okay? So that's how you multiply polynomial expressions.